Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, hi everybody. Right, in this video, I would like to share with you one of the topic in the vector algebra. Okay, vector in 2 and 3 dimensional space. Okay, there is a position vector. So, what is position vector? Okay, position vector is a vector which represents the position of an object in space in relation to an arbitrary initial frame of reference, referred to as a reference or location point that exists in 2 or 3 dimensional space. Right. So a position vector can be expressed as a linear combination of basis or standard vector. Right. Actually, position vector also we call as a standard vector. Okay, where a vector actually okay comes from the 2 point, and then by joining these 2 points, okay, we have a direction from point A to point B. So this is the vector AB. Okay, so to calculate the component of vector AB is by subtract point B to point A. Okay, and then for this case, okay, for a position vector, okay, the point A is origin. Okay, the point A is the origin. Therefore, if we have point B, okay, any point or any coordinate in the space 2 dimension, therefore vector AB is also element in the point B. Right. So for a position vector, actually is the point of the endpoint, okay, of the vector. Okay, and then we can write the vector, okay, just put one alphabet. Okay, let's say vector A, okay, 1 2, okay. So in a 2-dimensional space, vector A is actually okay, we have the endpoint of 1 2. Right, so this is the position vector. Right, next to share with you, okay, one of the topic, okay, direction cosines and direction angles. Right. Okay, normally for the direction cosine and angle, okay, we just ask you in the question, okay, for a vector in 3 dimensional space. Okay, let's say we have a vector u with the component a, b, c. Okay, then the direction cosines of the vector are, okay, we have 3 cosine, cos alpha, cos beta, and cos gamma. So cos alpha is a, which is the component, first component of u, divided by square root a square plus b square plus c square. Okay, if we look here, this is the magnitude of vector u. Okay, this is the formula for the magnitude of u. So we can write the cos alpha equal to a over magnitude u. And then for cos beta, okay, given by b over magnitude u, and cos gamma is given by c over magnitude u. Right. So this is the direction cosines, and we have another direction, is direction angles. Okay, where the direction angles is the value of alpha, beta, and gamma. So to find the value of alpha, we just inverse cos or arc cos to the a over magnitude u, and then for beta, arc cos b over magnitude u, and gamma, arc cos c over magnitude u. Right, so this 3 is the direction cosine, and this is the direction angle. Right, so what is the meaning of alpha, beta, and gamma in this case? So the direction angles alpha, beta, gamma are the angles that the vector makes with the positive x, y, and x and z axis respectively. Okay, if I can draw the three axes, okay, x, y, and z, okay, in three-dimensional space, and then we have one vector, one standard vector. Okay, let's say this is vector u. So the value of alpha is actually from the line of vector u to the x-axis. Then the value for beta is from the line u to y-axis, and the gamma value is an angle between vector u to z-axis. Right, so this is the meaning of the direction angle. Okay, then we have one formula. Okay, usually the direction cosines occur other than the direction angles. We have cos square alpha plus cos square beta plus cos square gamma equal to 1. Right, so we can use this formula, okay, if we want to recheck the answer of direction cosines. Okay, we just square all the values of direction cosines, and then the summation of the values here, we will get approaching number 1. Now we look at one example. Okay, we have the question: find the direction cosines and direction angles for a vector from point P to the point Q. Right, in this question, we have to find the vector PQ first, since we have 2 points P and Q. So firstly, we have to find the vector of PQ. Okay, please remember that to find the vector of PQ, we just subtract endpoint, that is Q, to P. Okay, so we have 1 minus negative 2, 7 minus 3, 5 minus 97. So this is the vector PQ. Okay, next step, okay, is to find the magnitude of vector PQ, okay, by using the formula square root 3 square plus 4 square plus 12 square. Okay, the answer is negative 13. So to find the direction cosines, we use the formula cos alpha cos alpha a over magnitude u. So this is a3 over magnitude pq 13. So the answer is 0.2308. Then cos beta, okay, second component 4 over magnitude pq, we will get 0.3077. And cos gamma, okay, third component, that is 12 over magnitude pq 13, and equal to 0.9231. So this is the direction cosines. Okay, so for the direction angles, okay, we just inverse cosine, okay, to the value of direction cosine. Okay, for example, for alpha, okay, we use arc cos or inverse cos 3 over 13, so we will get the angle, okay, in degree 76.66 degree. And for beta, arc cos 4 over 13, okay, the answer is 72.08 degree. And gamma, arc cos 12 over 13 equal to 22.62 degrees. So this is an example, okay, and hopefully you will understand, okay. And in this lesson, in this video, okay, there is direction cosines and direction angle.